All right, so in this section, section 4.4, we're going to talk about how to graph sine and cosine functions. So a sine function is going to look like this over here. Cosine function is going to look like this. Where does that come from? Well, first of all, domain is negative infinity to positive infinity, range is negative 1 to 1. As you can see, it's going to repeat itself every 2 pi. Okay. And the highest point is going to be positive 1. The lowest point is going to be negative 1. Where are those values coming from? Well, if you look carefully, this is 0, 0. This is pi over 2, 1, pi 0, 3 pi over 2, negative 1, and then 2 pi 0. Where do those values come from? If you recall the unit circle, you should know that for 0, 0, this point here is 1 comma 0. This point here is 0 comma 1. This is negative 1 comma 0 over here. So 1 0 0 1 negative 1 0, and then this one over here is 0 negative 1. So that's where these points come from. When x is 0, when for sine, yes, for sine function, you know that sine is y. So 0 1 0 negative 1. So 0 1 0 negative 1. 0 pi over 2 1 pi is 0, and then 3 pi over 2 is negative 1, and then 0, because those are sine values. For cosine, if you look over here, cosine 0 is 1, and then cosine pi over 2 is 0, and then cosine pi would be negative 1, and then cosine 3 pi over 2 would be 0 again, and then it just keeps repeating itself over and over again. So if you're going to be talking about the characteristics of the graph, domain is, you can go from negative infinity to positive infinity. The range is going to be from negative 1 to 1. Y-intercept for sine function is 0. X-intercept is going to be pi times n, and then being an element of the z of so an integer, essentially. It's going to be continuous, so no holes. Symmetry is symmetric about the origin. It's an odd function. Maximum at 1 of 1 at x pi over 2 plus 2n pi, because it's going to keep repeating itself every 2 pi. Minimum at negative 1, and x equals 3 pi over 2 plus 2n pi. So for cosine 0 is 1. Sine 0 is 0. Cosine 0 is 1. So you can look at the characteristics here and see for cosine, it's still going to be negative infinity to positive infinity, range negative 1 to 1. Y-intercept is 1. X-intercepts pi over 2 times n. So every pi over 2, if you multiply by an integer, you're going to get an x-intercept. It's continuous from negative infinity to positive infinity, symmetric about the y-axis. It's an even function. And the maximum is at 1 at x equals 2 times n times pi. So every 2 pi, you're going to get a max, and the minimum of negative 1 at x equals pi times 2n pi. And behavior does not exist, of course, because it's a periodic function, which means it's going to keep repeating itself. Okay? So now we're going to talk about the amplitude of a sine function. So vertical dilations are called affect the amplitude of sinusoidal function, which are our sine cosine functions. Okay? So the amplitude is essentially how high and how low it's going to go. The distance between the maximum and the minimum values of the function, and it's half the height of the function. So you should know that the general form for sine function is y equals a sine bx plus c plus d, and for cosine is y equals a cosine bx plus c plus d. Okay, and the amplitude is going to be that number in front of sine or cosine. So for instance, to graph a sinusoidal function of the form y equals a sine x or y equals a cosine x, plot the x-intercepts and then the parent sine or cosine function, and then the amplitude, absolute value of a, to plot the new max and min points. Okay? So in this case over here, let's take a look at 1a. For 1a, what's going to happen is that 1/3, instead of going from 1 to 1, it's going to go from 1/3 and negative 1/3. So if you're talking cosine 0 would be 1, but because you're multiplying by 1/3, it's just going to be 1/3. So this would be 0, this would be pi over 2, this would be pi, this would be 3 pi over 2, and then 2 pi. So it's going to be it's going to go, because it's cosine, it's going to go from 1/3 to 0 to negative 1/3 to 0 back to 1/3. Okay? So what changes here is the amplitude. Instead of being negative 1 and 1, it's going to be negative 1/3, positive 1/3. In this case, the amplitude is going to go from, it's going to be 5. So we're going to do for sine x, sine 0 is 0. So we're going to start at 0. And then this is going to be a positive 5, negative 5. So it go pi over 2, 0 pi over 2 pi, 3 pi over 2, and then 2 pi. So it goes sine 0 is 0, pi over 2 is 5, 0, negative 5, back to 0. Okay? And then over here, we have cosine x, positive 2 cosine x. So once again, on the x-axis, I'm going to have 0, pi over 2, pi, 3 pi over 2, and 2 pi. And my amplitude is 2. So cosine 0, instead of being 1, it's going to be positive 2. And it's going to go to negative 2. Positive 2, negative 2. So it goes this way. Okay? If that looks confusing, we can always take a look at decimals. And what you're going to see is that if you graph both, I will try all 3 examples here. So we started out with cosine x and 1/3 cosine x. So we can do y equals, cosine x, and then 1/3 cosine x. So as you can see here, the amplitude for the blue function, which is 1/3 cosine x, is a lot smaller than y equals cosine x. So at 0, 1/3 pi over 2, 0. This one here is pi, negative 1/3. And then we go to 3 pi over 2 is going to be 0. And then 2 pi is going to be positive 1/3. So you can try to enter those on Desmos and see what happens. So you get both functions graphed. Okay? So that's the amplitude. The amplitude is always going to be the number in front of sine or cosine, whatever is coming after that. Okay? All right, so reflections of sinusoidal functions. If you have a negative, such as in this case, instead of being a positive one, it's going to be negative 1/5. So we can sketch those functions. Sorry about that. So, okay, here we go. All right, okay. So now, cosine x, you already know what it looks like. Cosine x, we're going to have 0, oops, and then we have pi over 2 for our points on the x-axis. We're going to have pi, 3 pi over 2, and 2 pi. Okay, so at 0, cosine x would be 1, but in this case, because it's being transformed and the amplitude is negative 1/5, we're going to start at negative 1/5. Let me just erase this. So this would be negative 1/5, and this would be positive 1/5. So my amplitude is 1/5. Cosine 0 is going to be negative 1/5, then 0, then 1/5, then 0, then negative 1/5. So we have a full period there. So it's going to look like that. Okay? For sine x, and then negative for sine x is going to be reflected. So sine x would just be sine 0 is 0, but in this case, let's try to graph this. All right. So over here, we have 0, once again, pi over 2, pi, 3 pi over 2, and then 2 pi. So sine 0 is 0, but in this case, instead of being 1, it's going to be negative 4. So we're going to go down to negative 4. We're going to say this is negative 4, positive 4. So 0, and then instead of going to positive 1, we're going to go to negative 4, 0, positive 4, and a 0. So it's going to go like this. Okay? If you want to take a look at Desmos, sine x and negative 4 sine x, it would look like this, sine x and then negative 4 sine x, negative 4 sine x. So as you can see here, it goes sine 0 is 0, sine pi over 2. For this, in this case, it's going to be negative 4, 0, positive 4, 0. Okay? All right, so moving on. So we looked at the amplitude. Now we're going to look at periods. Periods of sine and cosine functions. How do I make this thing go back? I don't know. But hopefully I can figure out. Okay, well, Let's just take a look at this. So it says the period of a sinusoidal function is the distance between any two sets of repeating points on the graph of the function. So what we're talking is the interval before the graph starts to repeat itself. So it says for y equals a sine bx plus c plus d, and y equals a cosine bx plus c plus d, where b is not 0. The period is going to be 2 pi over b. That's what you need to remember. The period is 2 pi over b. Period, remember this, is 2 pi over absolute value of b. Okay? That's what is important. So in this case, they say describe how the graphs of f of x and g of x are related, then find the period of g of x and sketch at least one period of the function. Okay? So, how are they related? The period of the first one is just 2 pi. The period of the second one, the period of g of x, would be 2 pi over the absolute value of b, which in this case you have to remember is the same as cosine 1/2 x. So b is 1/2. 2 pi over absolute value of 1/2 is just 1/2, which means the period is going to be 4 pi. Okay? So the period of g of x is 4 pi. And then I think they asked to sketch one period. Is that right? Okay. So if you're going to sketch the period, then instead of going to 2 pi, you're going to have to go to 4 pi. So we're going to go ahead and sketch it. And it's going to look like this. Because I have to go all the way up to 4 pi. This is just going to be pi, 2 pi, 3 pi, 4 pi. So I know that cosine x, this is going to be 1, -1. So I would start cosine 0 is 1, cosine pi 0, -1, 0, 1. That's what my sketch would look like. Okay? If you want to confirm, go to decimals and do cosine x and cosine x over 2. So you can take a look, cosine x and then cosine x over 2. So as you can see here, the blue graph 0, 0, and then this point here is pi 0. This is 2 pi -1, 3 pi 0, and then you have 4 pi 1. Okay? So that makes sense. So the period there is going to be 4 pi, which is just what we did. All right? Okay. For the second one here, what's going to happen? Well, let's see. The period here is 2 pi. And in this case, for the transformation g of x, the period is going to be 2 pi over 3. Because b is 3, so that's what it's going to be. And then you can sketch. If you're going to sketch that, show it over here. So because I don't have much room, so sine x, sine 3x. Okay, so 2 pi over b, the period b, let's go back here. So for this one, the period would be 2 pi over 3, and then the increments would have to be 2 pi over 3 divided by 4, which is going to be pi over 6. So, as you can see here, 0, 0, pi over 6, 1, pi over 3, 1, pi over 2, negative 1, and then 2 pi over 3, 0. So that would be a full period. Okay, so my points, once again, would be 0, and then, not that one, 0, 0, pi over 6, pi over 3, so 0, 0, since they want me to sketch, 0, 0, pi over 6, 2 pi over 6, which should be pi over 3, then pi, and then pi plus pi over 6, which in this case you can pull for here. So 0, pi over 6, pi over 3, pi over 2, and 2 pi over 3. And once again, the amplitude is just 1, so it's going to be 1, negative 1, and it's a sine function, so 0, 1, 0, negative 1, 0. It's going to go like that. Okay? All right. Okay. Now we move to cosine x and cosine 1 over 4x. So once again, the period for this one is 2 pi. That's the parent function. This is b. So 2 pi over 1 over 4 is going to be the same as 2 pi times 4, which means the period is 8 pi. Okay, so if the period is 8 pi, the amplitude here is still from positive 1, negative 1, and we're doing cosine, so you're gonna, the increments 8 pi, so you're gonna go 2 pi, 4 pi, 6 pi, and 8 pi. That's a full cycle. So cosine 0 is 1, so it's gonna go like this, negative 1, 0, 1. Done. Okay, so the period is always 2 pi over p. P is the number in front of x. All right? Frequency of sine and cosine functions. The frequency of a sinusoidal function is the number of cycles the function completes in 1 unit interval. So before it starts to repeat itself. The frequency is the reciprocal of the period. So for y equals a sine bx plus c plus d, and y equals a cosine bx plus c plus d. So the frequency is 1 over the period. You know the period is 2 pi over p, so if you flip it, you get absolute value of p over 2 pi. So one example we have here is music. In the same scale, the C above middle C has a frequency of 524 hertz. Write an equation for a sine function that can be used to model the initial behavior of the sound wave associated with the C having an amplitude of 0.1. So I know it's going to be y equals, and the amplitude is 0.1, so 0.1 sine, and now I need to know what b is. I know that the period is 2 pi over b, and the frequency is absolute value of b over 2 pi. So if absolute value frequency is absolute value of b over 2 pi. So I'm going to say that 524 hertz is equal to absolute value of b over 2 pi. So if I multiply that by 2 pi, I get 1048 pi, sine 1048 pi times the time. So this would be my answer here. Okay. Okay. That would be the equation. And the final thing we need to know is something called the vertical shift or the vertical translation. So they say the final way to transform the graph of a sinusoidal function is through the vertical translation or vertical shift. Recall from lesson 5 that the graph of y equals f of x plus d is the graph of the parent function, y equals f of x, translated or shifted d, the absolute value of d units up if d is more than 0, or down if d is less than 0. Okay, the vertical shift is the average of the maximum and minimum values of the function. So the parent functions y equals sine x and y equals cosine x oscillate, meaning they go back and forth, the x-axis. After a vertical shift, the new horizontal axis, known as the midline, becomes the reference line or equilibrium point about which the graph oscillates. For instance, in this case, plus 1, y equals 1 is going to be that midline, okay? In general, the midline for graphs of y equals a sine bx plus c plus d and y equals a cosine bx plus c plus d is y equals d. So you just need to look at that last number in the equation. So for instance, over here, your midline is going to be this number. Over here, your midline is going to be this number, okay? So now they want you to do everything with this one. They want to know the amplitude, period, frequency, phase shift, and vertical shift of each function. And then you're supposed to graph. So let's just list the characteristics first. So the amplitude in this one would be the number in front. It would be 2. The period is 2 pi over b. In this case, b is 1, so 2 pi over here. And then they want to know the frequency. The frequency is going to be b over 2 pi. Or absolute value of b. And then they want to know the phase shift. So there are 2 ways to figure out the phase shift. You can do minus c over b, or which should be in this case. Oh, in this case, there's no parentheses. So it's just going to be, because that's the vertical shift. So it's just going to be there is no phase shift here, not a horizontal phase shift. It's just going to be a vertical phase shift. Okay, so we have the frequency, and then we are going to have 2 pi over b, 1 over 2 pi. Okay, so now vertical phase shift is 1 because of that plus 1. Okay, so as far as graphing, instead of trying to do this by hand, everything's going to be shifted 1 up, the amplitude is going to be 2, and there is really no horizontal translation, and the period is just going to be 2 pi. So 2 cosine x plus 1. I would just do cosine x. And then 2 cosine x. So you can clearly see here that there is no horizontal shift, right? The midline now is 0, 1, 2, 3. Okay, so yes, so this is the midline over here. Okay, so this point here is 0, 3. Remember, the amplitude is 2, but everything has been shifted up 1. So 0, 3, and then this point here is when pi negative 1. So 0, 3, pi negative 1, and then this would be yeah, 0, pi 2 pi over 2. Okay, so here you go. Yeah, so pi over 2. 1, 2, 1. Oh, here we go. It's kind of hard to see here, but in any case, so there should be a pi over 2 here. So 0, I'm not finding that point there, but you do have, yeah, 2 pi over 3. There should be a 0. This is pi, so there should be a pi over 2. And then this is a 2 pi. So that's a full cycle. Okay? Yeah, it's just not listing there. But it should be 0, and then pi over 2 would be a 1, and then pi negative 1, and then 3 pi over 2, 1, and then 2 pi would be a 3. Just for some reason, we're not able to find that point there, but that's what it would be. All right. Now this is a little trickier, but we can still do it. Amplitude is 1/2. Vertical shift is 3 down. And then the period is going to be so for this one, the horizontal shift is going to be minus c over b, but let's do one at a time. So amplitude would be 1/2. Let's do the easy ones first. Vertical shift would be 3 down. And then we have horizontal shift. There are 2 ways to do this. You can do minus c over b, or you can just set this whole thing here equal to 0. So if you do 1 over 4 minus pi over 2 equals 0, then you should be able to solve that. And you get, this is a 4, that pi over 2 is equal to 1 over 4th. Which should be I feel like I'm not seeing this very well. Yes, there's a x there. So 1x, now it makes sense. Okay, so then it would be pi over 2 times 4 on both sides. It would be 2 pi, so x equals 2 pi. So that would be the phase shift, the horizontal phase shift, which also you can do it by doing minus pi over 2 divided by pi over 4, which should be just 2 pi. And the period would be 2 pi over b. In this case, it's 1 over 4th, which gives you 8 pi. So that makes sense. It's going to be 0, 2 pi, 4 pi, 6 pi, 8 pi. Okay? And that's how you can graph. So I will do that. I'm going to do that one by hand. So I have 0, then it's going to be 2 pi, 4 pi, 6 pi, 8 pi. But remember, the horizontal shift is going to be 2 pi. And it's going to be 2 pi to the right. So I'm going to start over here. So here we go. So, yeah. So we're talking vertical shift 3 down, and it's 1/2. So that means the amplitude is 1/2. But I have to shift everything down 3 units. So 1, 2, 3, and then this one would be 1/2, which means this would be -3, -2.5, and this would be 3.5. Okay, so if we're talking sine function, so, and everything is going to be shifted 2 pi units. So sine, and that's going to start over here, and then it goes up here, down, and this is over here. So now I have the sketch of my function, but I know this looks rather confusing. So let's go ahead and enter this on decimal so it's clearer. 1/2 sine. Let's just do a regular sine x, and let's do a 1/2 sine 1/2, and then we're gonna do sine x over 4 minus pi over 2, x over 4 minus pi over 2, should be a pine button. Let me try this. Pi over 2. Pi over 2. Okay. And then we can do -3. 1/2 sine x over 4 minus pi over 2 minus 3. Oh, it's over 4. No, x over 4 minus pi over 2. Right. Okay, so we are good. So now, what it appears there, like we said before, is that the period is going to be 8 pi. So now we're talking, everything is going to be shifted. So we have 2 pi, we have 6 pi, and that repeats itself. So the period is 8 pi, and but it starts at 2 pi. So it starts at 2 pi. It's just that they went to 10 pi, or you can look at 0 and then the negative 3.5, or, oh, I don't know what this is doing. Never mind. Okay, but you get the idea in any case. I don't know why it's selecting that whole thing. So yeah, so you have all the characteristics there. That's what it takes care of that. I'm gonna submit some more examples at a later date, but you have the summary for graphs of sinusoidal functions. Y is equals to a sine bx plus c. So the amplitude is always that number in front of the function. This is your amplitude, how much is going to go up, down. Bx plus c. That's going to be related to the period and the horizontal phase shift. And this is going to be your vertical phase shift. Okay? Y equals a cosine bx plus c plus d is going to be the cosine function, transformations of cosine functions. Okay? Phase shift is minus c over absolute value of b. Amplitude is absolute value of a. Vertical shift is d. Period 2 pi over b, and frequency is absolute value of b over 2 pi, or 1 over the period. Midline is always the d. Okay? So we're going to spend a couple days on this. I know it's a lot of information, but at least you have a good start on this. Okay?